Can everyone hear me at the back? Give me a thumbs up if... All right, cool. So yeah, hello, I'm James. I'm going to talk to you about confident unit testing. So before I get started, I just want to prefix this as why do I want to show you the process that I'm about to show you? That comes down to why do we test our software? You may have heard the old excuse oh, I don't get paid to write tests. The client doesn't have the budget for tests. And that's right, you don't get paid for writing tests. You get paid for delivering value and solving people's problems. And so tests are really just cost. You can't sell your tests to anybody. They're not useful in and of themselves. We write them and we run them because we believe that they are cheaper than the alternative of not writing them in terms of achieving a certain level of quality that we want and avoiding potential problems for our users. If our software is not working, that may have serious consequences for people, and we'd like to avoid that. So we invest time and money in writing and running tests in order to avoid other costs for ourselves and our users. And for that trade-off to deliver good value, our tests should be as cost-effective as possible. They should be as cheap to execute as possible. And one thing I see a lot of teams struggling with is having a test suite that makes them feel really confident because it covers everything that they do, but it takes a really long time to run. So it actually takes up a lot of their company's time in paying just to run code that people are waiting on before they can ship stuff. So I'd like to show you a technique where you can get the same amount of confidence and spend much less time doing so. So I'm going to go through a little example application. This example app is very simple. It's just a sign-up page. And this sign-up page has a field for the username, the email address, and the password. If we enter invalid data in any of these fields, we get some validation errors, like the username cannot be blank, and the email must be a valid email address. But if we enter valid data, then we are registered on the site and we see our profile page that tells us our name and shows our email address. So this is a very simple application, doesn't do anything particularly useful, but it's just complicated enough to throw up some interesting testing problems. So let's look at how it's implemented internally. I wouldn't worry too much about the exact tools that I'm using here. If you're not familiar with any of these libraries, don't worry. The thing I'd like you to focus on here is the structure and the process that we're going through. You can apply this to pretty much whatever tool stack you're using. But what I've done here is I've used a library called Sequelize to make a model for the user that represents the users table in the database. It has a username, which is a string, and is validated to not be empty. It has an email field, which is also a string and is validated to be a valid address, and it has a password field, which is also a string. So that model helps us save things and retrieve them from the database. On top of that sits an Express application. That has a route for getting the sign-up page that just renders the template. That template, if it is given any errors, will list them out. And following that, we have the actual form for the sign-up field that has the username and the email, which echo the input that the user provided, and the password field that just always begins blank. That form submits to this Express request handler, which begins by building a new user from the request parameters that are provided. Then it attempts to validate the user, save it, and if that is successful, then we return a JSON response that tells the client to redirect to the user's profile page. If validating raises an error, then we instead return a list of errors to the client so it can respond appropriately. On the client side, we have a little bit of jQuery to go and get our form and handle form submissions ourselves rather than letting the browser submit the form. We're going to prevent that happening and handle it ourselves. And the way we're going to do that is with this handle signup function that takes the action and the parameters from the form, sends a post request to the server using that data, and then if the response is successful, then we redirect by changing the location object. Otherwise, we fall through and we display the list of errors that we got from the server. This function error list is just a helper that puts a list to hold the errors on the page if it doesn't exist already. So how should we go about testing this? Most teams will have some sort of full stack integration test system that simulates a real user interacting with your product, going through all of your pages, filling out forms, clicking links, and checking that everything works as expected. I've written some examples of testing in this style using a tool called Test Cafe. So in Test Cafe, you provide a name for your set of tests and tell it which URL the test should begin on. And then each test proceeds by submitting user input into the application. So here we're entering some data into the fields in the form and then clicking the submit button. And then to check that we've arrived in the right place, we want to look for the heading on the profile page and check that it contains the text that we're expecting. We can also check failure situations by entering invalid data and checking that we see the validation errors that we were expecting. So here we're omitting to fill in the username field and expecting that we get the username validation error. In this test, we're submitting an invalid email address and checking that we, again, get the appropriate response. So this being a full stack test, we need to clean up any state that's created in the database between each test. So after each test runs, we need to tell our user model to destroy any records that were saved while that test was running. So when we run this, Test Cafe will boot up a browser for us and make a connection to it. And then it will go through running all the code that we put in, running through the application. You'll see it filling out forms and stuff. And it will check everything works correctly. So when it finishes, it tells you the status of the tests and how long they took to run, 5 seconds. So a couple of seconds per test. If you get a failure, it shows you where in your test suite that failure occurred, which is really useful. So Test Cafe is a really nice user experience. It's probably the closest to like just working integration testing out of the box that I've ever seen. But in common with most tools in this category, it's quite slow, especially on failure. So if it fails to find a node that you're looking for on the page, it will try again a few times because it might be something asynchronous is happening. It needs to wait for that. So it'll try again a few times and eventually time out. And that failure adds another 10 seconds to the time your test takes to run. This is quite a common failure mode for integrated testing tools. So to sum up full stack testing, we like it because it makes us feel really confident because it's exercising our whole product. There's nothing fake going on there. We know everything's being run for real. However, it's very slow. Each test takes a long time to run. And that makes it very expensive. It means that you and your developer workflow spend a lot of time waiting. It means that your team spends a lot of time waiting for builds to go through CI before you can deploy stuff. It makes it harder for you to respond to change quickly, hard to respond to outages because getting new code shipped takes a long time. They also provide poor feedback. If the tests don't find a particular UI element that they were looking for, they don't tell you why that's the case. They just say, well, this isn't here. You figure it out. I don't know. They can also lead to non-deterministic outcomes. Like, for example, if your test is not waiting long enough for an AJAX response to come back or for an animation to finish, you can get failures that don't really indicate your software doesn't work. They're just your testing infrastructure is non-deterministic. They're also really highly coupled. Like to get your system to go into every particular state that it can have, you might need to provide quite a complicated amount of user input depending on what state you're trying to poke the system into. So your tests end up reproducing a lot of the details of how your system works. And that means that when you change the rules of how your system works, your tests can become very brittle. So they become very expensive to maintain as well as to run. So if that sounds like a long list of negatives, I'd also argue that the one positive at the top of the list is also misplaced. We shouldn't actually have this much confidence from integration testing. To actually get a reasonable amount of coverage of our applications, we have to cover off like every combination of states that every component involved in a scenario could be in. And that means writing quite a combinatorially large set of tests to get a reasonable amount of coverage. And usually running a test suite that large takes a prohibitive amount of time. so we don't bother. We just try to find the few cases that we care the most about and cover those off. It's not feasible to get a reasonable amount of coverage of everything our system could do using this technique. So how can we use unit testing to solve this problem? So I'm going to show you a process that you can apply at any level of your stack to make sure that you test what's important, you test it reliably, and that any assumptions you make are, and you also do that with a reasonable amount of confidence that the assumptions you make in your tests are really valid. So let's start at the edge of the system, the code on the client side that wires the form AJAX handling up. So this code has a problem with it, which is that it hooks some code up to run when the page loads. That means that we can't trigger the code whenever we want from a test suite. It just runs on page load and then it won't run again. So the first step in making this code testable is to take control of it. Get the code inside something that you can execute reliably. In this case, that just means wrapping the code in a normal named function instead of a document.ready hook. And then we can put a call to that function in the page after where the form that it is affecting appears. Just a little bit of extra plumbing, but it means the code can now be executed however we want. So we can now begin writing a test for this. We can write a test that puts some form HTML into the page and calls that function for us to wire up the event handlers. You could use your templates to generate this markup if you'd rather not reproduce how your views work. Personally, I like writing tests this way because by only including what HTML your JavaScript relies on, it clarifies the relationship between the JavaScript and what is needed in the DOM. So the next step is to isolate the dependencies, like identify which parts of the code that you're testing are either separate parts of your system that you'd like to test separately, or parts of the production environment that you don't actually have control over. So for example, our handle sign-up form performs a page redirect by interacting with the location object. So JavaScript unit tests on the client run inside a web page in a browser, and changing the location object would cause the browser to navigate away from the page where those tests are running. So we don't actually want that to happen because it would stop the test suite. So we need to be able to test this code we need to be able to test the handle sign-up function without actually executing this code. So we can do that by extracting that code into its own function that's sort of simple enough that we don't really need to test it, and then putting a call into that function from the thing we are trying to test. We can then stub that redirect function out in our test so that calling it has no effect, and our handle sign-up form can now be tested without unloading the page. The handle sign-up also relies on talking to the server via the jQuery post method. And we know that when we're running client-side unit tests, we don't really have a server running, so we need to sort of provide a canned response for what our client code will expect to receive from the server. So how do we identify what that should look like? Well, we go into our server-side code and we look at the request handler for that, and we can identify that there are some lines that tell us like where the response is generated. It's either has OK true with a redirect value or OK false with a list of errors. So in our tests, we can put together a sort of hard-coded value for a kind of response we could get, and then use stubbing to make jQuery return that response. Don't get too hung up on the fact that jQuery is talking to the server here. That is not really that important. Just think of it as a function that returns a value, in this case, a promise of a response, and stub it to return that kind of value in your tests. So once you've isolated your code from the environment, you can check the interactions. So we want to check that when we fill out data in the form and submit it, it sends the right data to the server. So we can do that using jQuery to fill out values in the form and trigger the submit event. And then we can check that the post method was called with the data that we expect. This is what spying is really great for. It's for testing side effects. So when you perform an action, you check that your component sends some data to another part of the system. So having checked that that interaction takes place, you should check what the possible outcomes of it could be. So for our client-side form handling code, we either know that the response will either be successful and will perform a redirect, or will fall through and will display the errors on the page. So we can handle that in our tests by saying, when the response is successful, we can stub and provide a successful response. then we check that the redirect is performed. So we can use our spy that we set up on the redirect function to check that that redirect function gets called, and that's how we know that the redirect is being done without it actually taking place, if that makes sense. When the server returns an error, we don't want to do that. So instead we can write a stub that returns a failed response and check that the redirect function is not called. So it's important to check that these different outcomes of the interaction produce different behavior in the thing that you're testing. If you're testing for something positive, always test that changing a decision produces the opposite outcome. We can also write a test at the end for checking that the errors from the response are displayed on the page. When we run these tests, you'll see that they run very, very quickly. You could run hundreds of these tests per second because they're not really interacting with the server. They're not doing anything particularly complicated other than just running your application code. The testing infrastructure isn't adding a lot of overhead. And you can write a test suite that checks a lot of very fine-grained details about your software very quickly, which makes it very cost-effective. So the final step in this process, that is where the restoring your confidence comes from, is verifying the assumptions that you've made in your tests. So look at everything that you've stubbed out, everything you've said about other parts of the system in the thing you've just tested, and verify that they're true. So in our example, our client-side code relies on this server-side request handler. So we'd like to be able to test this in a similar manner, check that the responses that we provided, the responses that we assumed in the test that we just wrote, actually take place when we test the request handler that generates those responses. So let's go through the process again one step down through the stack. First, we take control. Can we exercise this code by calling it in a controlled way and not just letting it happen implicitly? We can by just sending a request to the server, so that's taken care of. The second step is to isolate the dependencies. Like what things in this request handler are things we'd rather test separately that aren't really part of request handling per se. In this case, I'm going to decide that the interaction with the database isn't strictly part of this code. What this code's job is generating responses. So I'm going to fake out the database interaction. So we can see here we want to fake out the user.build method, and that is going to need to return a user that has a validate method, a save method, and an ID property. Again, you're just looking at this as like, what are functions called with and what do they return? Don't think of it as it's interacting with the database, just think of it as it's functions that return some values, and what do those values need to have in order to be acceptable. So we can create a fake user by using, in this case, Jasmine's spying functionality to create an object with validate and save methods and an ID property, and just stubbing user.build to return that. To check the interactions, we can use a library called supertest to send requests to our Express app. In this case, we're building up a set of parameters and using supertest to send it to the user's endpoint using the node query string module to serialize them. And then we want to check that the data that we put in the request actually gets passed through to the user.build method. Having done that, we want to check what the possible outcomes are. And the possible outcomes here are that the decision being made is whether the user is valid or not. That's if we call user.validate and we get a successful promise back, then we want to return a successful response. Otherwise, if that returns a rejected promise, then we're going to return a list of errors. So again, we can simulate that in our test suite by making the user.validate function return a resolved promise. Again, notice that we are triggering a certain path in the code here by just varying the result of the interaction with the validate method. We're not doing it by actually submitting valid user data, so we're not reproducing all the rules about what user data should look like. So we're not coupling this test to how the database looks or what the validation rules are. We're just using the variation in the thing we're testing to control its behavior. That reduces the coupling and it makes the test easier to maintain. So having set up that response, we can check that the user gets saved by checking that the user.save function gets called. And we can also check that it generates the right response, in this case a 302 redirect with the right location header to the user's profile. If we want to check an XHR request, all we need to do is add an extra header to our request to send the X requested with header that tells the server that it's an XHR, and then check that we get a 200 response instead with some JSON data. When the user is not valid, all we want to do is stub the validate method out to return some errors in the way that SQLize formats them. And then in that case, check that the user is not saved. Again, look at the redirect result earlier. We wanted to check redirect versus no redirect. Here we're checking saving versus not saving. Again, just by checking a function has been called. And then you just carry on down the stack, verifying your assumptions. So that request handler relied on the user model's validation method. We could write some tests for that, so make a function that validates the user and converts the promise into either an empty list or a list of the error messages, and check that making a user with valid parameters generates an empty list. Building a user with invalid data introduced generates a particular validation message. So in each test, we're introducing one deviation from valid data and checking that that produces the one validation message that we're expecting. If you want to test your templates independently, that's also usually pretty simple because templates are pure functions that just take some data and return some HTML, and they can be easily matched against CSS selectors. Tests like this are very, very, very fast because they don't perform any I/O, and you can often perform on the order of 1,000 of them per second. So you can get a lot of testing done very quickly. Yes, so you can also check stuff like details of the wiring of your application, like that the right form exists on the page, that it echoes the right values, that it submits to the right endpoint, all of this fine-grained detail that would usually be prohibitively expensive to do with integration testing. So the result of all this, I ended up writing 26 tests to convince myself that this application does what it was supposed to, which sounds like quite a lot, but they're all very short and they didn't take me a long time to write. And once you get practiced in this technique, you'll be able to do it fairly quickly. And they take almost no time to run. That's like 0.3 seconds. That's like sort of instantaneous almost. This lets you build up like a very detailed, complex test suite that takes a very, very small amount of time to run, and it radically changes your workflow both individually and as a team when you have a test suite that's this fast. So to go over the process one more time, you begin by taking control of the code you're trying to test. You isolate its dependencies, like remove anything that is out of scope for the thing that you're testing right now. Check the interaction with the other parts of the system that it depends on. Check how it handles the responses from those parts of the system, and then go one step down and repeat the process on everything that you've made assumptions about. So hopefully I've convinced you that unit testing can retain a similar amount of confidence to integration testing, but without all the expense of spending so much time doing so. If you're interested in these topics, I have a book on testing that has been out for a few years, but this is all still like very relevant information, and it's not really about the tools you're using, it's about the process and the practices that you apply. So thank you very much.